Hello everyone. Today shall discuss Today we shall discuss about comparing quantities. What is that? This is an introduction. In our daily life, there are many occasions when we compare two quantities. Suppose we are comparing heights of Hina and Amir. We find that Hina is 2 times taller than Amir, or Amir's height is 1 by 2 of Hira's height. Consider another example where 20 marbles are divided between Rita and Amit such that Rita has 12 marbles and Amit has 8 marbles. We say that Rita has 3 by 2 times the marbles that Amit has, or Amit has 2 by 3 part of what Rita has. Yet another example is where we compare the speeds of cheetah and a man. The speed of cheetah is 120 km per hour and the speed of man is 20 km per hour. The speed of cheetah is 6 times the speed of a man, or you can say the speed of a man is 1 by 6th of the speed of cheetah. Right? Do you remember comparisons like this? In class 6 we have learned to make comparisons by saying how many times one quantity is of the other. Here we see that it can also be inverted and written as what part of one quantity is of the other. In the given cases, we write the ratios of the heights as Hina's height is 2, Amit's height is 150 is to 75, that is 2 is to 1. Can we now write the ratios for other comparisons? There are relative comparisons and could be same for two different situations. If Hina's height was 150 centimeter and Amit's was 100 centimeter, then the ratio of their heights would be Hina's height is to Amit's height is 150 is to 100, that is 3 by 2. This is same as the ratio of Rita to Amit's share of marbles. Thus you see that the ratio for two different comparisons may be the same. Remember that to compare two quantities, the units must be same and a ratio has no units. Now learn about equivalent ratios. Different ratios can also be compared with each other to know whether they are equivalent or not. To do this, we need to write the ratios in the form of fractions and then compare them by converting them to like fractions. If these like fractions are equal, we say the given ratios are equivalent. Now, keeping things in proportion and getting solutions. Aruna made a sketch of the building she lives in and drew a sketch of her mother standing beside the building. Mona said, "There seems to be something wrong in that drawing." Can you say what is wrong? How can you say this? In this case, the ratio of heights in the drawing would be the same as the ratio of actual heights. That is, actual height of building divided by actual height of mother is equal to height of building in drawing divided by height of mother in the drawing. Only then would these be in proportion. Often, when proportions are maintained, the drawing seems pleasing to the eye. Another example where proportions are used is in the making of national flags. Do you know that the flags are always made in a fixed ratio of length to its breadth? This may be different for different countries, but mostly around 1.5 is to 1 or 1.7 is to 1. We can make an approximate value of the ratios as 3 is to 2. Even the Indian postcard is around the same ratio. Now we can take an approximate value of the ratio as 3 is to 2. Even the Indian postcard is around the same ratio. Can you say whether a card with length 4.5 cm and breadth 3 cm is near to this ratio? That is, we need to ask, is 4.5 is to 3 equivalent to 3 is to 2? 4.5 by 3, we are getting 3 is to 2. Hence we say that 4.5 is to 3 is equivalent to 3 is to 2. We see a wide use of such proportions in real life. Can you think of some more situations? We have also learnt a method in the earlier classes known as unitary method, in which we first find the value of one unit and then the value of the required number of units. Let us see how both the above methods help us to achieve the same thing. We can use either proportion method or method of unitary method to get the same result. Here you see a map is given with a scale of 2 cm is equal to 1000 km. What is the actual distance between the two places in kilometers if the distance in the map is 2.5 centimeter? Let's see, in this solution, Arun does it like this. Let's distance equal to x kilometer. Therefore, 1000 is to x is equal to 2 is to 2.5, or 1000 by x is equal to 2 by 2.5. Okay, and therefore x is equal to gives 1250 kilometer. And by unitary methods, 2 centimeter means 1000 kilometer. Therefore, 1 centimeter means 1000 by 2 kilometer. Hence, 2.5 centimeter means 1000 by 2 into 2.5 kilometer. That is 1250 kilometer. This is the unitary method, and this is the proportion method. Arun has solved it by equating ratios to make proportions, and then by solving the equation. Miraj first found the distance that corresponds to 1 centimeter, and then used to that to find what 2.5 centimeter would correspond to. So use the unitary method, right? That means we can use either the unitary method or the ratio method or proportion method to find the solution of the desired result, right? Here you see, in this method we first found the value for 1 unit or unit rate. This is done by the comparison of two different properties. For example, when we compare total cost to number of items, we get cost per item, or if we take distance doubled to time taken, we get distance per unit time. Thus, we can see that we often use per to mean for each. For example, kilometer per hour, children per teacher, etc. to denote unit rates. Right? In the next video, we will discuss the various exercises. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.